Hey guys, so this video is for questions 13 through 15. We've got a football kicked into the air at a speed of 24 meters per second at an angle of 60 degrees. So let's work through each one of these. For 13, you are finding horizontal and vertical components. That is your VIX and VIY. Anytime you are working with anything launched at an angle, you're gonna use these formulas, whether I ask you a question like 13 or if it's like the next set like 16 through 18 where you still got to do it even though I didn't ask you to do it. That's always going to be your step one, right? So your formulas are VIX equals VI times cosine theta. So for this you've got VI is 24 and then theta is 60. When you work that out, you should get, what was it, 12 as your answer, right? And then VIY is going to be VI sine theta. All right, so that's going to be 24 sine theta. That should give you an answer of 20.78 as your answer. So that's your first step in any of these that are launched at an angle. Those are going to be what you do first. So in your table, your VI are these numbers. So I have 12 and 20.78. All right. So you will not use the 24 or the 60 again when you're working this out. You're going to, from now on, use the 12 and 20.78. To go ahead and fill in what else we know that our acceleration is 0 and negative 9.8. We can fill in that. All right, let me erase some of this to make room. All right, so that is 13. For 14, we want to know how long the ball's in the air. When you're solving for this, the easiest way to do this is to find the time it takes to go halfway up. Our ball is launched and it forms a parabola shape when the football's kicked. So at this very top of the arc, or the parabola right here, for our vertical velocity, when it gets to this highest point, our final velocity at that moment would be 0. This is at that moment when the ball's going up, and right before it like comes back down. At that instant that it, as it changes from going up to going down, the velocity would be 0. So we can use that to find the time it takes it to get to that point, and then we'll double it to get the rest of the way. So the formula we're going to use is the VF equals VI formula. We're going to use vertical information, so I'm going to plug in the y's with it as well. All right, so we have 0 equals, our VIY that we found was 20.78 plus negative 9.8 times time. So in order to solve this, I'm going to subtract the 20.78 to the other side, if this will write. And that equals negative 9.8 times time. And then in order just to get time, we're going to divide, and that is going to get us 2.12 seconds. So it takes the football, 2.12 seconds to get to the highest point. Our question is asking how long it's in the air, so it's not going just to the highest point and just hanging out up there. It's going to come back down. So since we're ignoring air resistance, which is why it says neglect air resistance, the same amount of time it takes to go up in the air is going to be what it takes to come back down in the air. So we can multiply this by 2, and that's going to give us 4.24 seconds for our total time, right? With time, if you are solving for the height it's going to go, like you're going to do later on in number 17, you are going to use the half amount of time because it would take the ball only 2.12 seconds to get to this highest point. For 15, we are looking for the horizontal of how far away it's going to go. Like if we're kicking this at the 20-yard line, we want to know what yard line it would land at, kind of thing. So we would want to use the full 4.24 seconds. So the formula you're going to use for distance is, of course, going to be everyone's favorite distance formula. You're going to use it with the horizontal information. So keep in mind that your acceleration in the horizontal is always going to be 0. So this whole end of it gets canceled out. So you don't even have to waste your time filling it in. If you're like, hey, I know that's 0, I don't need to bother. All right, so you're going to plug in your VIX, which is 12, your full time, because we're looking for how long it travels horizontally. So we need the full amount of time. and you just multiply that, and you should get 50.88 meters as your answer. Okay, so we use the full amount of time because we're looking from start to finish how far it's gone. So that would take the full 4.25 seconds. Sorry, 4.24 seconds. If we were solving for height, which none of these ask you to do, but you will later, you would use half the amount of time because when it gets to this highest point, it's halfway there. So it would use half the time. All right. So I hope this video helps you out. Please let me know if you have any questions about it.